let's say 86% to make it easy number, right? So if we walk from left to right, from all the way to the left to the furthest right, we have 86% or 86. And if I walk from left to the lowest one, I have 4, right? So how do I find the item in between? Well, to find the item in between, do you agree that all I need to do is take 86 minus 4, right? I take the bigger percentage, 0.8643, minus the smaller percentage, which is 0.0446. So again, if I know the long way is this much and the short way is this much, how do I find the difference between? Well, to find the difference between, I just subtract the long, subtract the short, which is, do you agree that this is what I have, which is 8193.8197 is the area left over, right? So basically, this is what we have is, again, 81.97 is the percentage, okay? So again, to find the area between, basically, you're looking for the two z-score and subtract among themselves, okay? But always is always the higher percentage or the higher area minus the lower area, because we cannot use a negative number. Okay? So let's take a look at this thing here, which is, again, let's connect this back. Let's connect this back to the empirical rule. So again, you say, well, what's empirical rule? Well, reminder, last time empirical rule, I told you that if we go up one, down one, or if we go to the left one, to the right one, the answer is 68%. That's what the empirical rule says, within one standard deviation. So now, instead of say within one standard deviation, now they say find the area underneath the standard normal distribution between the z-score of -1 and the z-score of 1. Which is, again, everybody see that now, looking at this thing here, how do I find the item in between? Which is, again, I need to identify my z-score of -1, and I need to identify my z-score of 1, which is I locate my two z-score. Everybody see that? Which is, again, we know if you were to use empirical rule, the answer is 68%. That's what empirical rule say. But again, empirical rule is just basically estimate, make it easy for us to remember. Let's take a look at this thing here. Do you agree that -1 is 1587 and 1 is 0.8413, which is I have to take the bigger number 8413 minus the smaller number 1587 to find the middle of the item, which is, again, to find a percentage in between, which is, if you subtract them, you should see that it's 0.6826 or 68.26%. This is the exact percentage, ladies and gentlemen, 68.26, right? The empirical rule just say, oh, just forget about the 26 for now, just make it 68%, approximately 68%, make it easy for us to remember. That's what empirical rule is. Okay? So again, looking at this thing here, once we have this normal distribution table, we don't really need to know empirical rule. If they ask you -2 and 2, you just go identify where's your -2, where's your 2, you subtract among themselves, and the answer should be around 95%. It's 95.1 something, but again, they just say 95% for empirical rule. Okay, so again, that's the idea here. Is we try to find the percentage of the data between the two value, and I think Alex connect this to a percentile later, but again, I don't think I asked you any question related to percentile. But again, let's practice this thing here. Let's say if I ask you, let's say Alex asks you find the area underneath the curve between z of 1.5 and z of 1.9. So looking at this thing here, we got the z. Now we just need to know what is the area associated with the 1.5 and what's the area associated with the 1.9, which is, again, we go in, and as you can see, 1.5 is 0.9332 and 1.9 is 0.9713, which is, everybody see that, again, first we need to identify the z-score, and the area corresponds to that z-score. And now what do? I just take the bigger area minus the smaller area, which is 0.9713 minus 0.9332, which is, everybody agree that we have the leftover of 0.0381 or 3.81%. Okay. Question here. And again, ladies and gentlemen, one thing I want to point out that 11. This is 11.7 too. Okay, as you will see that we will translate this to 11.7. The only thing different in 11.7 is we have to do one small step before we can do this thing here. Any question here? Let's try one more. Right. Let's say again, same thing go. Let's say find the area between the z-score of negative 0.25 and a 0.95. And one thing, ladies and gentlemen, make sure you identify the right number. Sometimes your eye trick you. Is negative 0.25, not negative 2.5. Again, and this chart they have. This chart is they have the 0.05 down here, and there's a 0.50 up here. So make sure look at your chart carefully, right? But again, look at this thing here, which is again, if we're looking for a negative 0.25, this is what we have is 0.4013, and 0.95 is 8289. I think each problem I use 0.95, all three of them, right? So looking at this thing here, which is what do we need to do? We just need to take the bigger percentage or bigger area, 0.82 minus the 0.40, which is if you subtract this thing here, everybody see that we still have 4276 left, or 0.4276 left. Yeah. So again, hopefully you guys see that this is easier than try to remember empirical rule. And sometimes you guys say, oh, empirical rule, you don't see the use. It's just they try and make it easy for you to remember, right? 68, 95, 99.7. But with this method, we don't really need to remember empirical rule. And empirical rule cannot help you with this kind of problem here, which is negative 0.25 and 0.95. We cannot do that with empirical rule. You could, but it's very pain. Okay. So question with this 11.6. So if you don't have a question, let's take a look at 11.7. So this is the last section for this class, which is 11.7, which is how do we use a normal distribution table to answer your application problem, which is more word problems. So look at this thing here. I wrote this 4-step. And after a while, you will see that it's very consistently and it's very redundant. So this is the 4-step to solve your application problem. So the first step is you need to sketch or draw your normal distribution curve. It doesn't have to be perfect. It's just just sketch it, just give some curve, and then highlight the region that we're looking for. They are all, like I mentioned, 3 regions that they will ask you, which is the region to the left, the region to the right, or the region in between the 2 z-score, right? Those are only 3 questions they will ask you: region to the left, region to the right, or region between the 2 score, right? So highlight them, shade them, whatever you want to do. The only thing new, not really new, but the only thing that you need to do before you can look at your chart is you need to convert your data to the z-score. We have to find a z-score. They won't give you the z-score. And to find a z-score, if you look at if you watch the video from last Monday, to find a z-score, we take the data minus the mean divided by the standard deviation. And like I mentioned on last video or last meeting, this is what statistic is basically they will give you the formula. All you need to do is plug into the right item. So it's always the data minus the mean divided by the standard deviation for the z-score. Once you find the z-score, this is all you need to do is basically, again, locate your z-score on the table or in the table, right? The table that we've been using.